Yeah, you do.
Okay, so this is our final equation, h of x, and it came from multiplying two functions, so we have to think of two functions that would multiply to that. So I'm actually just going to factor this. So a 2x, a 1x, and I need a 3 and a 1, so I have to think about where to put that. So I'm going to do that to make a plus 6 minus 1. So that would work. So these are going to be my two functions. So I'm going to say f of x will equal that one, and g of x will equal that. Therefore, those two functions would multiply to the h function. You could also have written those, this one is the g and this is the f. That doesn't matter. Okay, given that f of x is 3, g of x is x plus 2, determine the domain and range of the division. Okay, so we would be worried about having a division by 0. So that's what we're worried about. Okay, so h of x equals f, so 3 over x plus 2. And I can't have that bottom being 0. So x is not allowed to be negative 2. So the domain is going to be, we can write negative infinity to negative 2 union negative 2 to infinity. That's one way you could write that. Or x is all real except for x is not negative 2. Okay, that's two ways you can write that. Let's talk about the range now. So this is a rational equation. So when we talk about, we would have had an asymptote there, right? And then the rules was the higher degree on the bottom. So when numbers become larger, they get the fraction, it gets closer to 0. So we would have an asymptote like that. So when we do rational, that's what our rules would be. So my range would go from negative infinity to 0 and then start again 0 to infinity. Or y can be any real number except for 0. F of x is x cubed, g of x is 2x minus 3. What is the value of f divided by g at negative 1? So f of x divided by g of x, so that would be x cubed over 2x minus 3. So putting a negative 1 into this, so negative 1 cubed is negative 1. And this makes negative 5. Then I'm going to simplify that. Two negatives make a positive. The x-intercept of the f function is 4. The x-intercept of the g function is 4. Ben concludes that the x-intercepts of the function, if I did a f of x plus g of x, is 8. Do you agree or not? So I would say no to this. So what is the reason? Okay, so if f of x would have the coordinate 4, 0, and g of x would have the coordinate 4, 0 as well, if those are the x-intercepts. So if you think about when you do a chart, if the x is 4, so if you think about those coordinates in a chart, and then you do the f of x plus the g of x, you would get the coordinate 4, 0. So the f of x plus the g of x has an x-intercept of 4, 0. So Ben mistake, he was adding the x instead of the y. Number 5, what's the domain of if we do the timesing? Okay, so f of x times g of x Okay, so if we think about this as a rational, we know that there's a non-permissible value at x equals 2. And then we cancel, and the function would be just 1. So thinking about this graphically, I would have a function y equals 1. And then there would be a hole there because that canceled. So this would be my graph. So then the domain would be negative infinity to 2, and then I can start again 2 to infinity, or x can be any real number except for 2. You can write your form in either of those ways. Okay, number 6. So the f function has a domain less than or equal to 2, and then the g is greater or equal to 7. State the domain when we add them together. Okay, so on a number line sense, if we do 2, we're here, and less than that, that's where that function is, the f function, and then the g is from negative 7 to infinity. So I can only do a composite function where they both exist. So therefore, from negative 7 to 2. Number 7, I was given this function, the f function, and then a g, and h is the subtraction. Determine the h function. Okay, so the h function is the f function minus the g function. So the f function minus the g function. And right now I'm putting brackets on that. So this is not important to do brackets on the first one. However, it is very important to do brackets on the second one because that will cause right here a mistake if you don't. Okay, so I'm going to put this all together. So x squared, 5x minus an x is 4x. 6 minus 3 is plus 3. So then I've been asked to graph this, so what do I know? I know it's a parabola. I know there's a y-intercept there. Quickly, I could factor 3 and 1. So I have oops, what did I do? So at 1 and 3, I have x-intercepts. I can move this point symmetric over there. If you need to get any more points, I'm going to do 2 comma. So now I'm going to plug 2 in. So 2 squared plus 4 times 2 plus 3. So 4 plus 8 plus 3. Hold on here. oh, why did I do this? Sorry guys. Backtracking here. There we go. Plus plus. So this is actually a minus and minus. That would make more sense. I'll flip that point. There we go. Okay, now I would like to do a negative 2. That makes more sense to me. So 4 minus 8. There we go. So that makes a negative 1. There. And now I can see my parabola. Okay, number 8. I have the f and the g. Determine the equation of f divided by g. Alright, so f of x divided by g of x. So the f function divided by the g function. Okay, I can leave like that, but to simplify it, I'm going to factor the top. Okay, so that could be an answer because it says just determine the equation. It doesn't say to simplify it, but I am going to simplify this. So factor GCF of 3 out, and then that would cancel, so I could also write that. And then let's talk about the non-permissible values. So x cannot equal 4. That's a non-permitted value. And since that was a cancel, it would be a hole in the graph. Okay, given this equation, determine 2 functions that could multiply to that. So I'm going to factor, so 2x and 1x. We need a 15, so 5 and 3 would work with a 10 and a 3. So minus 10 plus 3. Yep, that would factor. So let's say f of x is this, and then g of x is this one. And again, you could switch those two around, and that would be fine because order would not matter. Okay, number 10. Determine the f times the g function. Okay, I'm going to FOIL this out. So here we go. 2x cubed plus 2x minus x squared minus 1. And I can leave it like that. Some people like to write it in an order. So there is no name, like this isn't called h of x or y of x, so I leave it like that. So 2x cubed minus the x squared plus the 2x minus 1.